Well, hello my friends. Welcome to this episode of Tim's Awesome Projects. Today I'm going to be installing solar panels on this 2014 Jayco Baja 12E pop-up camper behind me. So the solar panels we're going to be installing are two of a Renogy 100 watt panels for a combined 200 watts. It came as a kit, so it has these hookup cables. It also included combiners. There's also a charge controller. It's rated at 30 amps max. And it comes with mounting brackets. So we're going to be mounting it using the roof rack system that's on the Baja, although I created these custom crossbars. And the end pieces were 3D printed, and they'll get locked in using these T-mount bolts. So some additional things that we'll be using is a penetration cover for the cables coming through the roof. I also have some extra solar cable connectors, and we're going to be installing a battery monitor system. This is an LTR16. I've never used this before. I'm kind of excited to try it out. The battery we're going to be using is a 12 volt 200 amp hour battery. It's rated at 2,560 watt hours. I've used a couple of these batteries and so far I've been pretty happy with them. We're also going to be putting in a 2,000 watt sine wave inverter. The only thing that would probably be powering off this would be occasionally a microwave, maybe a toaster oven, and possibly some small electronic devices. Everything else in the camper is either 12 volt or propane. With the inverter comes some hookup cables, and it also includes a remote panel. And I'm kind of interested in seeing how these USB charge ports work on that as well. We've also got a breaker, circuit breaker, 250 amps. I like this. It works good as a disconnect switch for your battery. You just press a button, it opens up, and your battery is disconnected. Also have a Expert Power 20 amp charger. This is made exclusively for lithium iron phosphate batteries. I also have some relays. The relays will be used to connect and disconnect between shore power and our inverter system. I also have some extra hookup cable, and I have some braided wire loom. So the cables that are going to come from the solar panels down through the roof are going to be exposed, and I want to be sure they have some protection. So the first thing I'm going to do is install these crossbars, and we're going to be straddling the roof just behind the air conditioner, and we're going to put in these T-bolts. Now I'm not going to tighten it all the way down now, so we can adjust it a little bit. And we'll stick the bolt through on that one. The 3D printed piece has some tabs on it which will keep the T-bolt from spinning and keeps it locked in place. And we got them where we can still slide them. Okay, so our next step is to install these mounting brackets. Now I'll tighten these down. The brackets are then installed on the other end of the panel and on both ends of the second panel. Cardboard has been placed on the roof to protect it from the solar panels during the install until they are positioned into place. The first panel is moved over towards the center of the roof. The second panel is also laid on the roof. The panels are then repositioned closer to where they will be mounted. They are placed near the edge of the camper to prevent the air conditioner from shading the panels when the sun is closer to the horizon. The panels are now being positioned onto the roof rack crossbars where they will be mounted. The panel brackets are fastened to the crossbars using self-tapping screws. This is repeated until all brackets are attached. The crossbars are now secured by tightening the T-bolts on the ends next to the panels. A measurement is taken of the distance from the crossbar to the end of the roof rack. This is then used to align the crossbar on the other side. The T-bolt can then be locked down. The span between the two crossbars is then set, and the remaining crossbar T-bolt is tightened. So now the next thing I'm going to do is get these cables tied together. The two solar panels are connected electrically using two combiners, one for the positive feed and one for the negative. Once a good position is determined for the combiners, they are zip tied in place to the crossbar. Additional wire ties are added to secure the combiners and to keep the wires from flopping on the roof. So I've got them both connected now, and I'm checking the output, and I'm close to 19 volts open circuit. That's pretty good considering they're sitting in the shade. Okay, so now I got the panels installed. Now you need to run the wiring down through the roof, but I want to drill through the roof with it down because I can actually go through the fabric siding with it folded up. And up she goes. Actually, that's as far up as I need to go because now I know I got everything out of the way. Cardboard is laid under the roof to help catch any debris while drilling a hole through the roof. A 1-inch hole saw is used to drill a hole through the roof. A grommet has been placed in the hole in the roof. The solar panel wires are first worked through the cable grips on the cover and then through the grommet. Sikaflex 291 marine sealant is applied around the grommet to keep it from working loose. Next, the sealant is applied to the cover. The wire penetration cover is now screwed down to the roof using stainless steel screws. So you can see the wires coming down from the ceiling. We'll take care of them later. But first, we need to get the J sofa out of the way to access the compartments below easier. This is done by removing 4 lag bolts, 1 in each of the corners. Once the lag bolts have been removed, the J sofa can be moved out of the way. The rear compartment has a plywood cover that also needs to be removed. There are 4 screws securing it in place. After removing the screws, it can be moved out of the way. Now that access has been gained, measurements are taken to determine the best arrangement of inverter, charger, and other components. The wires coming from the solar panels are covered with braided loom. They will then be secured and routed down to the compartments below. The lithium iron phosphate battery is placed in the front compartment and checked for a dry fit. The solar charge controller is mounted to the sidewall next to the battery. The solar panel wires are routed in the compartments up to the solar charge controller. With the wires connected to the solar panels, the polarity is checked by measuring with a voltmeter. I'm showing negative 20 volts, so that means this one here is my positive. Swap around just, make sure. Yep, so this one's my positive. I'm going to go ahead and put some red tape on that. With the polarity determined, the wires are labeled with identifying information. The solar panels are disconnected until the charge controller wiring is completed. So now the wiring from the solar panels are connected to the charge controller. Alright, so now we're going to mount the power inverter. Next we'll put the charger right here. The remaining wires from the battery system to the solar charger have been installed and now are being secured with wire ties to existing wire clamps along the wall. Shore power cable wires need to be relocated from the power converter load center to a DIN terminal strip. This is done without the shore power being connected. The 120 volt branch circuit that feeds outlets in the camper will get rerouted to transfer relays. Jumper wires are then installed back to the DIN connector strip and transfer relays. A DIN rail with wiring terminals and fuse holder was installed. All wiring connections to transfer relays have been connected. A 40 amp circuit breaker located to the right of the DIN terminal strips has also been installed. This connects and protects all 12 volt circuits to the battery except for the inverter. For documentation on complete wiring, visit timsap.com and follow links to the Jayco Solar project. Here you can see the inverter and battery charger after they have been wired. Screws have been removed from a divider which is removed to gain access for mounting the inverter control panel. A cutout has been made for the inverter control panel and it is dry fitted in place. A template is made for the battery monitor. It is then cut out. Folding it into quarters will then find the center of the cutout. This is used to align the hole saw to cut the opening. The inverter control panel is now connected and tested out. The inverter control panel can now be fastened in place with 4 screws. The battery monitor is now connected and put in place. The inverter can be controlled and the battery status can be monitored from one convenient location. With the inverter control panel and battery monitor installed, the divider can be reinstalled in the cabinet. The 250 amp circuit breaker is placed on the compartment divider wall near the battery. In the back corner, you can see the 500 amp shunt used for the battery monitor. A divider panel is now installed to protect the battery and wiring from items stowed under the J-sofa bench. Now I'd like to talk a little bit about the inverter control panel and the battery monitor. So up above we have the inverter control panel. There's an on-off button. You press and hold the button until the display lights up. Then it's going to show you on the left side an indicator of the battery voltage. It's going to give you the actual voltage readout at the top. It's going to give you your AC voltage output, the voltage and the frequency, 60 hertz. On the right hand side is a bar graph that indicates the load. So right now we don't have any load on it. And just as a demonstration, I'll turn on a toaster oven, which is going to pull a lot of current. So now you can see the load bar going up. This is a 2000 watt sine wave inverter, but it handles that microwave very, very well. And if you look at below that is the battery monitor, and right now we're pulling almost 130 amps heating that toaster oven. I'm going to turn the toaster oven back off. So now if we press the power button just momentarily, you notice the display went off, but our inverter is still on, still producing power. I just turned the display off. Press it again and the display will come up. To actually turn off the inverter, what we want to do is press and hold the power button. When the display goes off, now the inverter is off. Okay, the battery monitor down below, the button on the left, if you press that, it will give us a readout of our voltage. The middle button, if you press that, it will give an indication of our charge or discharge. And right now it's clouded back up again, so we're not getting much out of our solar panels. So it's less than an amp charge we're getting. If you press the set button again, it'll tell you the capacity of our battery. So we're at 198 amp hours. If you press the left button, it'll give you a percentage of charge. So we're at 99.3% charge. The little bar graph at the top is also a visual indicator of the battery capacity. And now if we hit the set button again, so we're looking at current. I should mention there's a little up arrow to the left of it, so it has a little plus sign on it. So that tells you we're charging. When it's discharging, it will have a down arrow with a negative. Now if you press these two outside buttons, I think I have to hold them a little bit, it'll turn on the backlighting. Yeah, the camera's picking that up too well. But it's the intensity of the light is flashing. That indicates that it's charging. So let me turn a little bit of I'll turn a load back on again. So it will be discharging. Oh, I gotta have the inverter on. There, now that we got a load on it, it just stays constantly lit, and my camera's not adjusting to the light level too well. So, and then if you want to eliminate that backlighting, just press both the arrow keys, and then the backlighting will go off.
This concludes this video of the solar project for the Jayco Baja pop-up camper. More information on this project can be found on timsap.com. To ensure you receive the latest videos on Tim's awesome projects, please click on the subscribe button, and don't forget to hit the like button if you enjoyed this video. Thank you.